Hi, this is the second part of our BlackBerry 10 C++ NDK tutorial, where I will focus on how to connect the Cascades QML part, which is the UI in BlackBerry 10, to Qt and to C++, so we can exchange data between both. But before I move on to the C++ and QML part, there's one little thing I have to add from the last setup part. Once you have installed the NDK, you can, and if you have it installed newly, you should click on Update Native SDK to update your SDK to the latest version. You also can get here, for example, to the API reference and to the Cascades homepage, to a Getting Started tutorial and to sample applications. Also, there has been a question about the setup for the simulator and how to get the simulator to run. As I mentioned, my own setup is to have the simulator running under Windows as an administrator, and the virtual machine runs my NDK setup. You find some additional help for this at the BlackBerry site, developer.blackberry.com, and where you can download the simulator. You'll find also help for configuring, improving performance, settings, etc. And if you go on a configuring, you'll find things which you can do for, as I said, the IP, etc. And this is probably the best place to look for all the forums. But let's get back to the IDE and take a look at some code. This is a QML project which I did for the last tutorial, and this time we're going to enhance it with C++ and see how we can communicate from QML to C++ and from C++ to QML. I have already made some changes to the C++ of this application, but before we will take a look at this, I'd like to change a little bit in the QML. For this application, first I'd like to rename it to list app, and we will not change the label anymore. And now I will add some needed new items, a list view, because we want to display things in a list, I think, this time, and add a container below it, and add in this container a few buttons. And I want this container also to have a layout, which is a stack layout, and that I now just give this save list and let's have a look how this will look in the simulator. Oh, storage password. Okay, here we are. Okay, so this is our layout. This is the list here in the middle, the white thing. There are not yet any items. With add to list we will change this, and we have a save list and a load list button, and let's make it a little bit more beautiful. As we write an application for a touch-based device, the buttons should always fill as much space as they can in the layout, so we will make this button span all the width of the display, and we will see if we can do the same with those both buttons here. And let's rerun it again in the simulator, and here it works, but down here not. That's interesting. So as we have seen, it is working for this button, but it's not working for those buttons here. And in order to make it work, I have now changed this to left and right, and also we need in the container to set an orientation, which we see here. It's currently to the left, and we set it to center. And actually, let's see if it's doing. Yes, now you see we have both buttons aligned proper in the view, and our app is ready to be edited with some C++ code. So as we did not see in the last part of the tutorial any C++, I will get this time started with the main CPP, and as we see in the source folder, all the C++ of our application is currently residing, and the includes here is more or less the system includes, as we can see. And if we quickly go through the main CPP file, this is the default template which we see now for the main CPP. It has several includes for the Cascades, a little bit includes which have to do with Qt and the translation. We're opening the namespace Cascades in the main file here, and we see it's just a normal main function with a Qt declaration export attribute before it. And in the main function we declare an application class and hand over the arguments to it. Afterwards comes a block which will handle the localization support, and then we create our main object, which will be the object which contains the logic for our application. And after this is created and it gets the application as a parent handed over, after that it's simply called application exec and our application starts to run. And if you go on and see in QML Hello World HPP that this is our main class which contains the application logic, and it's derived from QObject, and up here we have type def for a QList data model, which is a template class which can turn any class in the template for a list, and we use it to declare a QString list model for our purposes. And we make this a member of our class, and also we keep a pointer to the application, which is handed to us via the constructor. These three methods here are declared QInvocable, which means that we will later be able to call those methods from QML and hand over data or invoke our C++ code from QML. One is simply to add data to our model, and one is to save our model to a file, and the other one will load from a file the data. And we still have one slot here which will later be called from QML to be able to receive signals from QML to C++, and we also have a signal which we will send after we have loaded the data from a file to QML via data ready. And this is our main interface currently for this application, which contains our application logic. If we go on to the QML Hello World CPP, we see just a few includes for the file IO, for example. And this is a constructor here, where we first create a QML object, a QML document object, which is now the main document of our application. Afterwards we create our list model, and then we use setContext property to make QML know of the existence of this model and that we can access it from QML. And this is one of the possibilities to let QML access C++ objects. And we do the same with our main application object. We say main object and this. And after that we create a root object, which is the root object of our scene, and therefore we set it as an application at set scene, so application knows what scene to display once the application is running. And I have prepared the three invocable methods. Add data is very easy. We just call append from list model and add the data to the model. Then we have save data, where we save the data to a file, and each entry of the model is a new line, and we basically do this in the Qt style. And in load data, we're doing this in the STL or in the standard version with std if stream, and loading the data in a QString list. And once this is done, we still have to edit and say list model append list. And now, of course, if we only if we have successfully loaded the data, we want to emit data ready, so we have to move this up on the line here. And let's see if it compiles. And yeah, here we see our application. And I think next we need to see what changes we need to do to the QML so that we can interact with our C++ code. So we move on again to the QML file, and I have already added here on clicked in the first button, and we just say main object and add data and say text field text, and we're done, and this is the simplest call which we can do. Now we still have to add on clicked to our other buttons, and add here main object. You see it's not loading in the IDE, so we have to say here save data and unclicked main object data. And let's see if this works. We simply enter some text to the list, and we see this part is already working. We can send data from the QML part to the C++ part, save it in the model, and then again get it displayed in our list view. And now let's save this. And so let's restart the application, and then we should be able to load the our saved file. And as we see, this is not working, and the reason why it's not working is that we have here with the application directory path a false print. This is actually the directory where the executable of the application is, but we know that this application is running in a sandbox, and we're not allowed to create files in this directory. And if we want to access the data directory of the application, we have to use the working path, which is in this case simply data/list.txt. So if we change this and compile again, we should be able to store and reload into our application. So let's try it again if it works this time, and we simply enter again text to our model, click save, restart the application. Now we load, now it works. So now we have the possibility to communicate with C++ and to add and save our data to a file in C++. And the missing part, which is now still to see how we can deal with signals from QML and with in QML with signals from C++. So I've made some changes now to the QML in order to receive signals we need to connect to those signals, and in our case this is a signal of the main object, which is called data_ready, and we connect it to our JavaScript function called onDataReady. And if we receive it, we will simply change the text of our label to data_ready. And sending a signal from QML is also pretty easy. We have to define the signal. We write signal, the name, and braces. And I've added a button to emit the signal, and it's simply the function signature, and this will emit the signal. And in C++, I've edited the receive signal method and make it receive signal from QML, add to the list model so we can see it in the application, and we still have to connect it. So we have the root object here. We say the signal from the root object we want to connect to our slot receive signal from QML, and the data_ready is emitted in the load data as we have seen before. So let's test that and restart the application. Now when the application is restarted, we should be able to send a signal. Yeah, this works. We could send a signal to the C++ part. We received it, and we see that this is now being displayed in our model. And we go in load list, and yeah, if we get the data_ready, we change the text of the label. So this is how you can send signals and emit signals from either C++ or QML and receive them in the other part. And this is the end of the second part of the tutorial, and I think we're going to take a look a little bit more on the Cascades APIs in the third part.